Hey, this is Mrs. Ross, and this is part 2 of Module B, Unit 1, Lesson 2, Notes. My last video got cut off, so I'm going to start back here. Let me erase all of this. We'll start with this quick check. If you already have some of this, you can speed this part up. If it didn't come out in the last video, then you can pause it so you can write it down. Okay. So this question, there are actually 3 parts. There's the first part, the second part. Oh, I did this last time too, darn it. Second part and the third part. Okay, so the first part, where it says, how did Dimitri reach his conclusion? And I think I covered this pretty well, but I'm going to say it at least once. Dimitri identified the cells based on his observation of a cell wall, a central vacuole, and the presence of chloroplasts. So he knows that this is a plant cell because of the cell wall, the central vacuole, and the presence of chloroplasts. Number 2, is his conclusion correct? It is correct because these organelles are not found in animal cells. It is correct because these organelles are not found in animal cells. Sorry, I forgot that was there. And then lastly, cells contain certain, what does it say? What life process can these cells carry out that a cell from another kind of multicellular organism cannot? So these cells contain chloroplasts so they can carry out photosynthesis. Animal cells cannot photosynthesize. These cells, these plant cells, contain chloroplasts so they can carry out photosynthesis. And plant cells do not photosynthesize. Okay. That said, why do scientists use models? Let's kind of scroll this up a little bit, see if we can find that. That's on page 25. What page are we on? We are on page 23. So that's 23, 24, this is 25. And the question is, why do scientists use models? Let's see, blah, blah. Scientists use models for many reasons. Models can show objects or processes that are too small or happen too slowly or too rapidly to see with the unaided eye. That's what you're going to write here. Models can show objects or processes that are too small or that happen too slowly or too rapidly to see with the unaided eye. You'll write that down. And then we have another quick check. Cells must perform many of the same types of function as body systems do. Which of these pairs correctly matches the cell organelle with the body system that performs a similar function? Let's see. What cells must perform? There it is. So sorry. Nucleus and nervous system. So the nucleus is kind of like the brain of the cell. This is Golgi complex and integumentary system, like as if the Golgi complex was a skin. It's not. Cell membrane and skeletal system. Maybe if it said cell wall and skeletal system, that would be different. And lysosome and circulatory system, that's not going to work. So, and why do cells vary in size? That's on page 29. Let's see. Got a lot going on here. Where in the world is page 29? Hallelujah, we found it. Okay. Let's see. Let's see. While some cells can grow larger, the reason has to do with the cell's surface area to volume ratio. The cell's surface is a total surface, its volume. Well, that really doesn't tell you why they vary in size. Let's see if it's further up here. Blah, blah. Cell size can vary based on their function. That's it. I skipped it. So sorry. So why do cells vary in size? Because of their function. Cell sizes can vary based on their function. So let's see where we're at here. Okay, I think we're on the last page. We're on the last page. All right. What is the relationship between surface area and volume? Why is there a limit to how large a cell can grow? Let's see. But there's a limit to how quickly these materials... nope, not it. Oh, here we go. Oh, no, that's not it. Could it be up there? Why do materials move through the cell membrane quickly? So the answer to this one, hold on, I know I have to come back here. Don't worry. The answer to this one is because a cell is small and has a small internal volume in relation to its surface area, materials are able to move through its cell membrane quickly. So because a cell is small and has a small internal volume in relation to its surface area, materials are able to move through its cell membrane quickly. And then what happens if a cell gets too big? I haven't forgotten. What happens if a cell gets too big? But there's a limit to how quickly this can grow. If a cell is too big, waste cannot properly exit the cell and nutrients cannot enter it quickly enough to fuel cell processes. So we have two problems that happen if a cell gets too big. Waste cannot exit it and nutrients can't enter fast enough. Okay? And then we have a quick check, but let me see if I can go back and see why is there a limit to how... here we go. While some cells can grow larger than other cells, there's a limit to how large a cell can grow. The reason has to do with the cell's surface area to volume ratio. So why is there a limit? The cell's surface area to volume ratio tells us how large a cell can be. Okay, if it gets larger, then it gets greater in volume in relation to its surface area, and it could get too large. So the limit is found in the surface area to volume ratio. So that's the answer to this question right here. Why is there a limit to how large you can grow? Because there is a limit to the surface area to volume ratio. Okay, and then we have our last quick check here. It says, what might happen if the cell gets too large? The cell's surface area will not be sufficient to take in enough nutrients and water or rid itself of waste. If the cell gets too large, the cell's surface area will not be sufficient to take in enough nutrients and water or rid itself of waste. And I think that is all. Please let me know if you have any questions.